There are a few odds and ends that we haven't covered from this chapter yet, so let's take a look at that real quickly. For example, we can specify the game version given by a string here, and that is useful to have players only connect to other players using the same game version or the same client version. Now, that will be used here. So we set this public static property of the Photon network class to our game version. So here it will effectively be set to 1 if we use this string. So that is pretty simple. What else is here? At the end of this page, we have this serialized field max players per room equals 4. The maximum number of players you can have in a Photon cloud, be it the free version or the most pricey version, is 16 players. So Photon is not made for MMORPGs. That's quite evident. Now, what is this byte type? It's pretty cool in C#. I don't always praise C#, but I do like that it has a byte type. C and C++ do not. You have to use char, I think. So what is a byte type? It's an 8-bit integer. Now, as I said, you can't have more than 16 players, so why do you need 32 bits to represent such a small amount of possibilities? Use an 8-bit integer. Okay. How do we actually use this? Well, we use it here. So remember when we created the room, there was this room options. So you can instantiate a new room options object, and since it has a max players property which is public, you can use this syntax to quickly initialize that new room with max players per room. Now, this is not a constructor, it's not a parametric constructor, it's just a C# syntax, which is kind of like an init list in C++. And that's it for chapter 1. Let's finally move on to something else. Chapter 2 begins by describing how to set up a scene to create a nice UI. Well, I'm not really sure if it's nice, because it's just describing functionality here, but let's try and make it nice. So I'm going to follow these steps and show you what my result is. As you can see, I've invested a whole lot of time and money in developing the most beautiful and gorgeous UI ever. Okay, so all jokes aside, notice how I started the game and nothing's getting called. That's because my start function here for my test pun component is gone. If I click on this, however, once things become responsive, there we go, I'm calling my connect function and everything else happens as a result of that. So on my button here, I actually have a button component that has this onClick event, and it gets triggered once I click the button, obviously. And once triggered, it calls all the associated callbacks, and here I have that connect method for my test pun component. And remember when I said that method needs to be public? Well, this is one of the reasons why. This following section is all about player information, just like every player's individual name, for example. Here's a heads up, we won't be using any external databases for storing player preferences, character information, and so on. We could, but it's not necessary for our cases, and we aren't creating something like an MMORPG. What we will be using is this player prefs, which kind of acts like a local database to store our player preferences and information. And then we can use that information online somehow. So let's take a crack at that. Let's have a quick look at the code here. Now, notice player name pref key, key as in key value. So think of associative arrays, hash maps, dictionaries, or even databases. It's all pretty much the same thing when you think about it. We have a value associated to a certain key that gets stored in some sort of data structure. And the key here is not going to change, constant. We call it player name. What does change is the value we associate to that key. And that's done here. So player prefs is a class, and it has the setString static method that creates a pair of key and value. This value is coming in from here, our setPlayerName function. Let's take a look at player prefs actually in code. I'm specifically opening up my code here using Writer, since Writer comes with other JetBrains functionalities, such as ReSharper and the JetBrains decompiler. Now if I write player prefs, which is a class, it's a type, I can press F12 to go to the source. But I don't have the source code because I've imported that type using this library, which is a DLL. But the decompiler, however, can do that job for me. So I can just go here, press F12, and it's actually going to decompile it for me, so we can see the message here. And it's actually not too bad. So we can see that this class has just a bunch of static methods or static functions. Some of them are extern that we saw in a previous lab. That means that their implementation is in some native library, which will be a C++ Unity engine library. Here we have setString that we saw previously. And yeah, it's not all that complicated. A whole lot of the implementation is actually abstracted away from us because it's done natively. So this is just like a C# wrapper, and it's an API. Okay, so that's done. Now let's start injecting some of this code from the tutorial into our actual project. I'm not going to copy paste the exact code that we saw in the tutorial. I'm just going to do things a bit more, let's say, my way. To start, I'm going to add a new input field to the canvas. Now remember, every UI layer element, you see here, UI layer, must be in a canvas for proper rendering and interaction. Speaking of interaction, really make sure you have your event system here. Okay. And now I'm also going to create a new game object that I will call Game Manager. It's going to manage like overall states of my game, including some UI stuff. So I'm actually going to create another script that's going to be specifically for UI management, put it in my game manager, and we'll do our connections with player prefs through that script. Okay, so here's my code. Now I have this const string player name pref key equals player name. This is quite similar to the tutorial. And just remember here that const variables in C# at least are by default static. In C and C++, you need to opt in to const static, but in C# they are always static. Now I have my set player name, which will take in this player name value of type string, and I'm doing an is null or white space check to make sure that the player name is valid. In the code here, we see that they are using is null or empty. What's the difference between that and white space? Well, let's say that the player in the input field enters 3 spaces. So the string is of length 3. It has 3 characters, but they're all invisible characters that we call white space characters. So spaces, tabs, and other things like that, they're white spaces. In the tutorial version, it will accept that, but I don't want to accept that. So I don't want any null string. Let's say that player name is null, like this. I don't want that. I don't want an empty string, but I don't want this kind of stuff either. So that's why I use is null or white space. Now if it is, I simply return, and if it's not, I create my key pair value and I set it in my player prefs. Back in the editor, I renamed my input field if player name. Notice how it actually has this component called input field. And that component has these 2 events, on value changed and on end edit. So what this tutorial is saying is that we should connect this set player name to the on value change event. Now I actually quickly changed my code in UI script. Let me show that to you. Just to debug.log every time the method, this function is going to get called. Here it is. So every time set player name is going to be called, I'm going to do this log. Okay, so let's go back to here. Input field on value change. I'm going to give it my game manager because that's the object that contains my UI manager component, which has this set player name function. And notice here, the event is type string, meaning that the function or the callback that we are going to attach, or the callbacks that we are going to attach, all must be functions that take a string parameter and also return void, just to be precise here. Okay, so let's try that out. I'm going to write something here. Okay, so I pressed one key and already we can notice, let me just expand this, okay? We can notice that the callback occurred, A, B, C, D. So every time I modify a text, even when I remove a character, I'm calling setPlayerName. I'm not a huge fan of this. I rather only update the player name and save it in my player prefs. Not every time I change, the string here, but only when I'm done editing the string. So I'm not agreeing with the tutorial here. I'm just going to change this to be using onEndEdit instead. My manager, set player name. Okay. Let's try this out one more time. Notice how there's nothing in the terminal. I'm going to press enter. And my cursor is not blinking anymore because I lost focus of the input field. And we can definitely see that it called my setPlayerName at the end of that. Let's say I start modifying it once more. I go out of focus, and here it is once more. A note about our design pattern here. So this specific input field is not necessary to set the player name. I have a function here called setPlayerName that has a responsibility of modifying this player prefs database. But I could use a different input field to call this setPlayerName, or I could use no UI elements, no view elements at all. Why am I saying this? Well, I just want to show how we decoupled things in an MVC fashion. MVC for Model View Controller that you're most likely familiar with. This UI manager acts as the controller. I could even rename it UI controller if I wanted to. So the view element here would be our input field. But as I previously mentioned, our final logic, what we really want to do, this setPlayerName, isn't tightly coupled to this specific input field, which is great. And in typical MVC fashion, we are connecting this view element just to a specific action in our controllers. So here we have it in the form of callbacks. This view element is communicating with the controller with this callback here that will be triggered at this event. And then the controller is communicating with the model on line 12. So yeah, we are respecting good decoupling in an MVC style. Simply setting a string in our player prefs really has no impact on our Photon business. Now, player prefs is not really tied to Photon in any specific way. It has nothing to do specifically with multiplayer. But before we actually see how to tie this up with Photon, let's see how we can use playerprefs.getString after setting a string. So I'm going to take a text field. So private text, I want to call this player name label, and I need to add a using here. It's going to be unityengine.ui.text. Okay, we see it here now, line 2. And this label, I want to set the text to be the text that I set previously in player prefs for the player name pref key. Now, I'm going to create, oops, sorry about that. I will create this, just 1 second, reorganize my code. Okay, let's create an awake function. And I'm going to take this player name label, which can be any one that I plug in through the inspector. Text equals player prefs dot get string, and let's put in our key. So that's player name pref key. Okay, let's go back into the editor. All right, now I'm going to add an element to the canvas called text, which is really just a simple label. I'm just going to put it here. Okay, and now in my UI manager, I will connect that text. I really should name it something actually. So I'm going to name it player name, or actually I'm going to start with LBL for like label, and here write player name. Okay. Now connect this like that. Let's start the game. And we see that it actually has my name here. Okay, let me change it to something a bit cleaner. So Kyle, do this. Okay, now notice how nowhere in my code I said to update this label. That's why it's not changed. I'm going to start once more. Awake is going to be called, and hey, there we go. So that's pretty cool. It saved it in between playing and not playing. I saved my scene, then I closed the editor. And the test I want to do now is open my project up once more, start it, and see if my name is still there. And if it is, what does that imply? So let's start. And there's my name. Awesome. Which means that this player prefs thing, it's not volatile. It doesn't only exist during runtime. It must be saved somewhere on my local computer in some sort of file. Okay, so where would that file actually be, and what does it look like? Let's have a quick look. According to the official player prefs documentation, your file will be located in a different place depending on your platform. So on macOS, it's in this pretty standard location, library preferences. On Linux, it's in your .config files, again, pretty standard. Windows Store apps, so if you're building UWP, it's going to be in app data local. Again, that's pretty standard for Windows. Here on Android, it's in this location. Windows Phone, it's not even worth talking about. But on typical Windows, so if you're just building like, standalone Windows Unity projects, it's going to be in HKCU. Now, if that doesn't make you shiver, let me explain what that is. Oops, sorry about that. It's the Windows registry, which served a purpose back in like Windows 95, and nowadays it's just this, in my opinion, it's a pain. Now, if you love the Windows registry, love what you love, no judgment, but I'm not a huge fan of it. Anyways, at least now you know where you can find the information. I really like it when it's in this file format here, like on Linux, Mac, and whatnot, because it's just this text-based file which works with tags like XML or HTML, and we can just easily read and change the information here without having to open up like the Windows registry and whatnot. So we can actually see an entry here done by Photon, PUN Cloud Best Region. Now remember, in the Unity editor, I don't have it open, so let's forget about showing you, but recall that when we did our first test with Korea, it saved the best region for Korea. Then when we allowed all regions, it saved the best region to be CAE because I'm situated near Montreal. And here we have our player name. So we see type string, and then we have the name here, which is encoded. Nice. Now that we have a better understanding of the player prefs mechanism, let's test out an edge case. So let's say that our player prefs does not contain our key value pair on awake because the set name was never done, or that for some reason it got deleted. Like here on line 13, I'm simulating this case by deleting the key manually, and then what I'm going to do is try and do this, player prefs.getString once more and return the length. Now this key value pair should not exist anymore, so what do we expect? Should this return null and we get an exception? Does just nothing happen? Let's test it out. Okay, and we get length 0, which means that this does not crash. It returns an empty string. How do I feel about that? I don't know. I kind of wish that it would crash with an exception, because I just enjoy it more when it's really in my face, so I can really notice the bugs. And this is not necessarily a bug, but it really feels to me like something that we could accidentally miss in a large-scale project. Like, we expect it to return something that's not empty, but it really does, but we don't notice it because the project is so big until it's too late and we already shipped the game. So personally, I just really like when things explode and crash because I'm forced to realize the potential errors. Okay, so I updated my code now. Notice this string text equals playerprefs.getString. So I'm going to take for granted that the key exists, and I'm going to load up the value associated to it and store it in the string variable. But if it doesn't exist for some reason, those reasons being that you accidentally deleted your playerprefs file, or you modified your registry, or just the first time you load up the game on your computer, the text is going to be set to no name found. So this is not like an exception because it's not ultra rare. It doesn't fall into unexpected behavior because I do expect this to occur when it's the first time you play the game, for example. But it will happen very rarely. So I'm putting it in this if. So I'm branching out on the very rare occasion. And I'm taking for granted that most of the time the key value pair will exist. So finally, then I set player name label.text to that text value. In terms of set player name, I've removed the debug.log calls and added this line to update the text with the player name. Now, I'm not always a big fan of this kind of strong coupling between a view element and this logic here, even though it does make sense in a controller, and I don't want to make things really over-engineered with MVC or other architectures similar to it, like MVVM or MVP. But I'm just taking some time to say that, yeah, there's this view element here in my code. It seems like some sort of strong dependence, even though it's quite normal for controllers. What would I do instead? Maybe use like an observer pattern here. So I would have things observing the player name, and I can attach callbacks. Now, here on line 25, I could change this line of code to invoke all those callbacks. So whenever the player name changes, I notify the observers, and they do what they want. It's like this text box could be one potential thing observing the player name, and whenever player name changes, it gets notified and it updates its own text. I would like that instead of this, but oh well, we have enough to go through, so let's carry on. Let's test. Now notice how my file does not contain my key, so no name found here, and write my name, click out. The file isn't updated until we stop the player. So I'm going to stop the player, look at the file once more. Here we have it, player name. And here's something sneaky that I'm going to try and do. I'm going to close the editor. Okay, and come here and change the value. I'm going to change the value to, let's say, 3 spaces and save. Now open up my project once more in the editor. And what's going to happen? No name found. Okay, so that's actually quite interesting. What happens if I exit here and I come back? Oh, there's nothing there. So when there's this invalid entry, it actually gets pruned out. Now let's try something else again. Okay, Kyle. Okay, save that to the file. See it here. Close the editor. And let's try something else. What would be a couple of spaces? Okay, if I try this, like an empty string, does this actually work? Unity Hub, Photon Lab. Let's start. And okay, it's invisible. Let's take a look at our code. So UI Manager, edit script. Okay, UI Manager script. So it did find a value, which is why we don't have no name found. But it just so happens that the text here that we read on this line is empty because it never went through this validation step. Now, how do we fix this? This is quite obscure, but I thought it was interesting to actually really think about different ways we can go ahead breaking our expected implementations. So I want to change something here. I'm going to do set player name. There we go. Set player name to text. And then it's going to do the verification here. And instead of just returning, what we can do is set player name to... there are so many things we can do here. How about we just actually throw an exception? Throw new... Well, actually we shouldn't throw an exception, because if somebody just enters space in the input field, then I'm going to crash the game. So that's not really appropriate. Let's do something really simple, like set the player name to a default value that we're going to call default name. Okay, so let's try this one more time. I forgot to stop this. Okay, let's go ahead. Default name. Okay, that's great. So now Kyle, that's updated. Let's look here. Okay, now we actually have my name encoded right there. By the way, I have no idea what the encoding is. Let's try this one more time, and I should see my name. Okay, there we go. So that was quite an interesting to look out for. And finally, line 27. This is where we set the player name to our client with photonnetwork.nickname equals player name. What's left in chapter 2? We have the connection process, but we're just going to skip over this stuff because it's only some UI business that has nothing to do with functionality. It's just to tell the client, tell the player that, okay, we are connecting, or hey, you got disconnected, by turning some text on or off with set active. So progress label, control panel, I think these are like just some simple text stuff to keep you informed. But we're using the console anyways to display some information about connection, so I think that's good enough. Now we can finally move on to part 3, game scenes. I think it's finally time to take another break. So stretch your legs, get some water, do some exercise, take a nap or something. And once we get back, we're going to get into some more interesting things, I believe, because we're going to finally talk about game scenes and loading a different game scene depending on the maximum number of players for a given room. If we have only 2 players for a room, let's give them a small map to play around with in a scene. If we have 16 players, let's give them a different scene with a bigger map. I hope you enjoy.